Good morning, class 9th. Today I am going to continue your exercise 1.3, and in previous class I am completing up to question number 2. Now we start question number 3 of exercise 1.3. So what is the question? Just look at the question first. Express the following in the form of P by Q, where P and Q are integers and Q is not equal to 0, and the first part is what? 0.6 bar. It is your first point. Okay, 0.6 bar. So what is the meaning of 0.6 bar? First let me explain here. Meaning of 0.6 bar. Okay, so what is the meaning? 0.6 bar, if you want to write it, becomes like that one, 0.6666 dot 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 dot. So it is what? Non terminating. It is non terminating but repeating decimal. It is non-terminating but repeating decimal. It means that it is a rational number. So the question asks you that you have to write 0.6 bar in the form of P by Q, where P and Q are integers and Q is not equal to 0. It means 0.6 bar you have to convert in the form of P by Q. Now I will tell you the step first in detail, then we come on the question. So first of all, you have to check whether is decimal is just near to the bar or not. If it is near to the bar, then it is okay. If it is not near to the bar, so first we bring it near the bar, then we continue our question. Okay, so now the bar is only on one number na, so we have to multiply by this 10. Okay, if the bar on the 2 number, then we multiply by 100. If the bar on the 3 number, we have to multiply by 1000. Like that one we have to do. These are the steps only. Firstly, I am telling you in a detail the basic as a basic concept. When we explain the question, then we understand all in detail. Okay, now I come on this proper solution now. And now just look at the question. The question is like that one. Your question is 0.6 bar. So what you do? First you have to write let x is equal to 0.6 bar. First you have to write let x is equal to 0.6 bar. Can we write 0.6 bar as 0.666 dot 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 dot? It is, you have to write this as equation number 2. Now bar is on the bar is present only on the one digit na, so you have to multiply by 10 on both sides. If the bar is present on 2 digit, then you have to multiply by 100. It is a working rule. Okay, so when you multiply by 10 on both side, so what you get? It become 10x, and you know the shortcut, it is mr. If you multiply, then decimal move to the right side. One is dl. When you divide, then decimal shift to left side is the shortcut. Okay, so what I am telling, when you multiply, it is move to the right side. Now you multiply by 10, then decimal moves to right side to one place. It becomes 6.66 dot dot dot. Okay, so now can you write 6.66 dot 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 as 6 as it is, and 66 dot 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 can you write here 6 bar? So it becomes 6.6 bar. Now it is equation number 3rd. Now just see, just look at your first equation. First equation you have to write 0.6 bar, and third equation you have to make here 6.6 bar. Now you have to subtract both these equation. Subtract equation number 1 from equation number 3rd. Now just do subtraction here in simple form, then I will explain there. You get 10x is equal to 6.6 bar in equation number 3rd, and equation number 4th is 0.6 bar. When you subtract, what will you get? Here you get simply a 9x, and here 6 bar both are same, it becomes 0 and become only 6. So you get 9x is equal to only 6, because 0 after decimal is useless, so we can't write. So it become x is equal to 6 by 9. Now just cut 3 2 is 6, 3 3 is 9. So what you get? 3 2 is 9. Just wait 1 minute. So you get here 3 2 is 6, 3 3 is 9. So finally you get 2 by 3. Now I'm explaining in detail here. Now when you subtract, what you will get? 10x minus x, and here get 6.6 bar minus 6 bar. So when you divide, when you subtract, it becomes 9x, it becomes 6.0 only, as I show the calculation. Then x is equal to 9 come in divide, it becomes 6 by 9. Now just cut 3 to the 6, 3 3 is 9, it becomes 2 by 3. And what is the value you let x you let 0.6 bar na. So 0.6 bar is equal to 2.2 upon 3. It is your proper answer. Now you can write 0.6 bar is equal to 2 by 3. It is in the form of p by q, where p and q are integer and q is not equal to 0. So it is your proper answer. Okay, now come on second part. In second part, 0.47 bar. So as I told you in detail that first decimal is present just near the bar. So your question is like that one again I am explaining here. 0.47 bar. Okay, so now just check the decimal is not present near to this bar na. So first we have to bring this decimal near to that bar. So what we do, if we multiply by 10, so this decimal shift to this side or not. So just write here, let x is equal to 0.47 bar first, and then multiply by x, then it becomes 4.7 bar. When you multiply by 10, this shift to the right side, it becomes 4.7 bar. Now decimal becomes near the bar. Now you have to follow the previous step as I told here. Now just look here. Now question is 0.47 bar. So write let x is equal to 0.47 bar, equation number first. So you multiply by 10. You multiply by 10 because you want to shift this decimal near to this bar. Okay, so when you multiply by 10, it becomes 10x, and it become, when decimal move to this side, it becomes 4.7 bar. It become equation number 2. Now question started from here. Now 10x you write here, 10x is equal to 4.7 bar, or 10x is equal to 4.77 dot dot dot. Now bar is only on the one digit na, so you have to multiply by 10 on both sides. So multiply by 10 again, it become 100x, and when this decimal move shift to this side, it become 47.77 bar. So 47 as it is, dot as it is, and 77 dot 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 means 7 bar. So you have to write 47.7 bar, equation number 4. Now you subtract 47.7 bar and 4 you have to subtract equation number 2 from equation number 4. So what you get, you have to write here equation number 4 first, because from 4 you have to subtract 100x. Equation 2, 10x, you get 47.7 bar, you get 4.7 bar. Now subtract 47.7 bar and you have to subtract 4.7 bar. So they are same, it becomes 0, and 47 minus 4 you get here 43. Okay, you get here 43. So what you get, so this side you get 90x, this side you get 43 only. X is equal to 43 by 90. This side come in divide, it becomes 43 by 90. Now what is the value of x you let here? You let here 0.47 bar. So what is the value? This 0.47 is equal to 43 by 90. It is your proper answer. Okay, hope all of you understand. If still you have any doubt, you can ask for my personal number. Now come on the next question. 0.001 bar. Now bar is present on the 3 digit. Okay, no problem. First you have to check there bar is just this bar is just near to the decimal or not. First we have to check this bar is just near to the decimal or not. Just wait, next I am bringing. Question is 0.001 bar. So now the bar is on the 3 digit, it's okay, but the decimal is present near the bar, so there is no need to shift the decimal. Now bar is on the 3 digit, so you have to multiply by 1000. This time you have to multiply by 1000. Okay, on both sides, and then continue the previous steps. Now come on the question, just see here. You get here, let x is equal to 0.001 bar, equation number first you have to let here. Okay, now x is equal to, now just repeat the digit 0.001, 0.001, 0.001 dot 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 dot, equation number 2. Now how many the bar is present, how many digit? 3 digit na, so you have to multiply 1000 on both sides. So multiply by 1000, it become 1000x. Now this decimal move to 3 place to the right side, because MR means multiply, you have to shift to right side na. So 3, if they shift to 3 place, it become here 1 2 3. So it become here, it become after this place 3 digit. Okay, so right here 1.001001 dot 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 dot. Okay, now can you write here 1.001001 dot dot, can you write here 001 bar here, because 001 001 001 dot 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 are here. So right here 1.001 bar. Now subtract this equation from the first one, as we do in previous question also. Now subtract, so what you get, 1000x minus x, here 1.001 bar, here 0.001 bar. So when you subtract, what you get, here you get 999x, and here you get this, both digit are same now, so it become here 0, and 1 minus 0 become 1, so you get only 1 here. Okay, so what is your answer? X is equal to 1 upon 999, 1 upon 999. And what is the value of x here? Value of x is 0.001 bar is equal to 1 upon 999. It is your answer. It is the proper method to write the terminating, non-terminating but repeating decimal into the form of p by q. Okay, it is your proper answer. So hope all of you understand all this three part. If you have any doubt, you can ask me. Now come on the question number 4. Express 0.99999 dot 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 dot. So what is the meaning of that? 0.9 meaning is same na. Can we write here 0.9 as 0.9 bar? Can we, because these are the repeating na, so we write here 0.9 bar. So the question is same. First part we study at 0.6 bar, it is 0.9 bar, so all are same na, only in place of 6 9 will come here. So the same question, so just look at this solution also. So you have to write here first, let x is equal to 0.999 dot bar. Can we write here 0.9 bar? Now multiply equation 1 by 10 on both side, so it become 10x here. Now decimal shift to this side, it become 9.99999, like that one they come. So when you multiply, it become this. So right here 0.9 bar, in this place you have to write here 9 bar. Now subtract equation number 2 from equation number 3rd. So equation number 3rd is 10x, equation number 2 you get here x, here 9.9 bar, and here you get 0.9 bar. Just look on one again. Second also you look, second is x is equal to 0.9 bar, and is 10x is equal to 9.9 bar. So like that one you have to subtract. 10x is equal to 9.9 bar, and you get here x is equal to 0.9 bar. Now subtract, what will you get here? It becomes 0, it become only 9, it become 9x. So the 9x is equal to 9 you get here. Just see, 9x is equal to 9 you get here. So when you find the value of x, then what will become? 9x is equal to 9 you get, then x is equal to 9 by 9, just cut by 1, then x is equal to 1. What is the value of x you get here? 0.9 bar, it is equal to 1. It is your answer. Now just see here, 0.9 bar is equal to 1. It is your final answer. Okay, so all these 4 questions are same, and that 3 question 3 part, and question number 4 all are same. There are some example which is just like this question, only digit are changed, so you have to try that example of NCERT in homework. Okay, if you have any doubt, you can ask me. Now come on question number 5. Question number 5 is a lengthy question. Question number 5 is that what can be the maximum number of digit be in the repeating block of the digit in the decimal expansion of 1 by 17. Perform the long division to check the answer. Okay, first I am going to explain what is the question. Okay, first I am going to explain what is the question. Question is that if you perform 1 upon 17 by long division method, suppose 1.00 we can increase, right here 17, in the table of 17 1 not come, so you have to take 2 digits become 10, and then write 1 decimal here. Now 10 will also not come, then you take 1 0, it become 100. Now write 1 0 here. Now in the table of 17 you check how many time 100 come, like that one you have to perform log division. Now you have to check whether if you continue divide, then after how many digit they are start repeating, like that one 8.6666. so after one digit they repeat 6.474747, then 2 digit repeat, like that one you have to tell how many digit are repeat there in that division 1 upon 17. So what you do, first you have to divide actually 1 by 17, by a long division. You have to do the calculation. Now your question started with 1. Now you have to check your remainder. If in your remainder you get 1, it means the digit start repeat at that time. You started question on the 1. When you divide, sometime you get remainder. So you have to check when you get 1 again as a remainder, it means you start your division again na. So up to that place your digit is repeated. Now I am showing you by the actual calculation. Just see here now. It is 1 upon 17. So 1 upon 17 you have to write here 1.0000. In the table of 17 1 not come, okay, then you take 2 digit, it become 10. In the table of 17 10 not come, so you write here 0 decimal. Now write 1 digit more, it become 100, and you have to write 1 0 here. Now it become 100. Now 17 5 is 85, it become 15. So here remainder is what, 15. So you have to continue that long division up to when you get the remainder 1. When you get the remainder 1, then you will get a stop. Okay, so it become 15, then write other 0, it become 150. Then 17 8 is what you get here, 136. You subtract, again you get 14, then write 1 0, it become 140. Then 17 8 is again you get 136. Now you get here 4 as a remainder, write 1 0, it become 40. Then 72 is a 34, again you get here 6. So like that one, if you perform this long division as I solve here, because you know very well how to perform long division, so it is already present here, just understand by yourself. So when you divide this long division, so finally you get 1 at the last. Here you get here beta 1 you get here. So when you get here 1, and if you want to continue your divide, then again you get the same answer whatever you get upside, because you start here from the 1 na, you start here from the 1. So you get 0.058823529411764 like that one you have to get. Okay, so again you get here 1. If you start one other further division, again you get the same number. It means that after 7 the digit will start repeated. After 7 you will again get 058823594117647 like that one you have to get. So you have to continue this long division. Finally you get here 1 by performing this long division. It means that digit start repeated after this 7. Okay, so you write here after long division 1 upon 17 is equal to 0.058823529411767 bar. So how many digits are repeated? Just check. You have to check now how many digits are repeated. Their question are asking how many digits are repeating. Now just I am going to zoom and then just count how many digits are there. Okay, now just check. It is 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 digits are repeated. So you have to write here, in it a block of 16 digits is repeated. The question is asking how many digits are repeated in their block. So you have to write here, in it a block of 16 digits is repeated, and the question say that you have to check by performing actual long division. Just see the question. Question is said what, perform the long division to check your answer. So we have to perform the long division here. Now we check our answer. Answer is 16 digits are repeated. Okay, this question is not important from the examination point of view. Same question number 6, it is for the knowledge purpose only, to clear a basic concept for the completion point, but not from the examination point of view. Question number 6 is like that. Look at the several example of rational number in the form of p by q, where q is not equal to 0, where p and q are integer with no common factor other than 1 and having terminating decimal representation. Can you guess what is the property of q must satisfied? Okay, beta, I am going to this question in detail on a whiteboard. Just see, I take a next page. Now see here, question is say like that one. Suppose you have any rational number, it is in the form of p by q, where q is not equal to 0. First thing. Second thing, they told is a terminating. So I am taking a example of terminating here. Terminating, suppose I am writing here 0.25 for example. So it is terminating decimal or not? It is terminating decimal or not? Definitely terminating decimal, because it is not divided further. So can we write here 25 upon 100? Now just cut 25 on the 25, 25 4 is 100. You get here 1 upon 4, 1 upon 4. Now they are asking if it is terminating decimal. If it is terminating decimal, so one example you get here 1 upon 4. Okay. So they are asking what is the property of q. Q is here 100 or here is 4. If it is in the lowest form, then your answer is 4. So they are asking what is the property q must satisfied. Okay. Just see. So beta, if it is, suppose it is terminating decimal 0.36, suppose it is terminating decimal, so can we write here 36 upon 100. Okay. Or if you take simple example, because it is a language question only, now I am taking to solve express only with the help of simple example. Okay. Suppose you have to take 0.3 only first. So it is terminating decimal or not? So write here 3 upon 10. So what is the property of 10? Can we write here 10 as 2 into 2? 2 into 5. It is terminating only when you divide it by 10. Okay. And 10 we can write here 2 and 5. It means that it is here, it is the place of q or not. So what is the property of q? Q has a factor of 2 or factor of 5 or both. If you divide any number by 2, then you get a terminating decimal. If you divide by 5, then you get terminating decimal. If you divide by 10, again you get terminating decimal. Now I am showing you with one common example. Now see, suppose 25, 25 and 25 divided by here 2, here 5, here 10. One example I am taking. Then you get here 12.5, here you get here 5, and here you get here 2.5. So it is a terminating decimal. Can you write here 5.0 to the terminating decimal? It is a terminating decimal. So what is the property of q? These are q or not? So they may contain a factor of 2 or 5 or both. So when they contain the factor of 2, 5 or both, then they are known as terminating decimal. Terminating means it is they are divided by 10. Okay. Now just read the answer. The prime factorization of q has only power of 2. Power of 2, they have a factor of power. So 4 is there. Then 4 means 2 into 2. Can you write here 2 ki power 2 na? So power of 2 means they have some power. It may be 2 or 3, whatever it was. So the prime factorization of q has only power of 2 or power of 5 or both. Both means 10. If they have the both, that 2 into 5, it means they become 10. So if they have 10, they become what? Terminating decimal. So it is a just example question only. It is for the purpose to increase your basic knowledge only. It is not a calculation purpose. And this question may be asked in the multiple choice question. Okay. So if the rational number is terminating, then what is the property of q? The question is like that one. If rational number is terminating, then what is the property of q? Property of q, as I told, terminating means 10 is there, 10 means 2 may be there, or 5 may be there, or both means 10 may be there. So you have to write here the prime factorization of q has only power of 2 or power of 5 or both. It is your answer. Okay. Hope all of you understand. Come on, the next question. Write 3 numbers whose decimal expansion are non-terminating and non-recurring. Non-recurring means non-repeating. So you can take a different example, as I told you in basic concept also, as I remember. Like that one I told you, if it is 0.25, that is known as terminating. Okay, it is 0.25, 2.25 dot 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 dot. It is non-terminating and non-repeating. Okay. And if write here like that one, 0.25, 26, 27, 28 dot 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 dot. So it is non-terminating and non-repeating. These are the example of terminating. It is non-terminating but repeating. It is known as non-terminating and non-repeating. It means it does not stop also, it does not repeat also. So it is known as non-terminating and non-repeating. Now come on the question. So there are many different example, or there are many answer, but I am writing here the Ncert answer only. Those numbers whose decimal expansion are non-terminating, non-repeating are, first write is 0.01. So just see here, it is not stop, so it is non-terminating. And can this repeating stack here 01, then 001, then 0001. It means that it does not repeat also. So it is the example of non-terminating and non-repeating. Now take 02, 002, 0002, 402, 502, like that one. So it is non-terminating and non-repeating. Now take 03, 003, 0003. Now take 403, and then 503 like that one you can take. So it is the example of non-terminating and non-repeating because digit are not repeated here. Okay, now come on question number 8. Find three different irrational number between the rational number. Okay, in first exercise we have to study to determine the rational number between them, but they are asking now you have to write irrational number between that two rational number. Understand? Now come on the number, what rational number we have? We have 5 by 7 and 9 by 11. We have two rational number, 5 by 7 and 9 by 11. So when you divide 5 by 7, here I am performing the long division. So what you get? Now just see, you have to start with 5 and you continue, you again get 5 here. Now I'm not going to explain this divide because it is a very easy one. In the table of 7, 5 not come, you take 2, it become 50. Now write here 0 point. Now 7 7 is 49, minus you got here 1, write 1 0, become 10, then 7 1 is 7. It is very easy. From class 3rd onward we study that method now. So you have to continue until you get the same number. You get here 5, here again you get here 5. So what are the numbers? 0.714285 dot dot dot. It means you get the same digit again. Now when you divide 11 by 9, again you get here 9 very soon. So it becomes 0.818181 like that one. Okay. So when you divide, you get this two number. So right here 5.7 is equal to 0.74825 bar. Bar means because 5 you get na, again you get the same answer when you divide, and 9 upon 11 you get 0.81 bar. Now these are the two rational number. And you have to write here three irrational number. Irrational number means non-terminating and non-repeating. Irrational number are non-terminating and non-repeating. Okay. Now just see. So it is just like 0.71, 0.81. So you can write any number between 0.71 and 0.81 in such a way that they are non-terminating and non-repeating. If you write any number between 0.71 and 0.81 in such a way that they are non-terminating and non-repeating, so they are known as what? Irrational number. Now just see, I am writing here 750, 0.71. You have to write between 0.71 and 0.81 now. So I'm writing here 0.750. First I write 0.75, then write 10, then 7.00, 7.000 and so on. So it is non-terminating and non-repeating, so it is an irrational number between them. Okay. Now come on second one, 760, then 7600, 7600 dot dot dot. So it is also known as irrational number between them. Now third one, you can write either 77 or 78 or 79. I'm writing here 80, then 800, then 8000 and 840 dot 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 dot. All number are written in that form. They are non-terminating and non-repeating. If the form is non-terminating and non-repeating, so they are known as what? Irrational number. So you have to write three irrational number in the two rational number, 5 upon 7 and 9 upon 11. It is your answer. Okay, you can get different answer for that question. Okay, either you can write here 77770 7700 like that one, or you can write 780 788 but you don't write 71 and 81. Between them you have to write. Now that's why. Now come on question number 8. Before start question number 8, I am explaining some basic concept. In that question you have to explain, or you have to tell that what are the rational number, irrational number. So one again I am telling here in detail, those number which are in the under root form and we did not get proper answer. Suppose 25 is there, so finally you get here 5, so it is a rational number because in the form of p by q, it is a what? Rational number. Okay. So and some under root like that one, if you want to solve, did not get proper answer. So those number which are in a under root form and does not solve, so they are known as irrational number. And those number which are in under root form but you can solve easily, they are known as what? Rational number. Okay. And second important thing I explained in basic concept also, if you have one rational number and two rational number, then you add, again you get a new rational number. When you subtract, again you get a new rational number. When you multiply, again when you divide again. It is the basic concept now. So if you have your two rational number, when you add, minus, multiply, divide, then always you get a new rational number. Okay, now suppose you have a one irrational number, suppose s, and one rational number. So when you plus, minus, multiply, divide, every time you get an irrational number. Okay, this is the basic concept I explain also there. Now come on the exercise. Now just see here. Classify the following number as rational and irrational. Root under root 3. So are you able to solve root under root 3? If it is root under root 25, then directly you can get 5 now. So it is a rational number. But root under root 20 is not able to solve now. So it is an irrational number. Okay. Now root 2 to 5. So when you do factor, it become 15 into 15. You get here 15. And we write here 15 as 15 by 1. So it is a rational number. In the form of p by q now. That's why. Now come on the next 0.3796. Beta, this is a terminating or not? I told you in basic concept also one important thing. One again I am going to remind that concept also. If the number is terminating and non-terminating but repeating, so they both represent what? Rational number. They both represent rational number. If it is terminating and non-terminating but repeating, then it is not what? Rational number. Okay, and it is non-terminating and non-repeating, so they are known as what? Irrational number. Okay, so now just see here, it is terminating decimal or not? It is terminating decimal, so it represents what? Rational number. By that definition, it represents rational number. Now come on that question. It is non-terminating but repeating. 478, 47 are repeating or not? So non-terminating but repeating also represent rational number. So you have to write it. So it is a rational number. Now come on that one. It is non-terminating. It is repeat. It become 10, then 100,000 and 10,000 like that one. So it is non-terminating and non-repeating. So it represent irrational number. It represent what, beta? Irrational number by that definition. Okay. So all this question is complete. This exercise also complete. So if you have any doubt in any question, you can ask me now. Thank you.